Alright, so this LeetCode question is called remove duplicates from sorted array. Right off the bat, I want to say that I don't like the name of this because the final result they want is not an array with the duplicates removed. What they really want is the count of non-duplicates from a sorted array. So it would have been better if they named it something like count non-duplicates in sorted array or count uniques in sorted array. Anyway, so let's get to it. It says, given a sorted array nums, remove the duplicates in place such that each element appear only once and return the new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O of 1 extra memory. So they do not want you to create a new array. They want you to do everything in the array that you're given. So example 1, given nums equals an array 1, 1, 2, your function should return length equals 2, with the first two elements of nums being 1 and 2 respectively. It doesn't matter what you leave beyond the returned length. So in this example, the unique elements are the numbers 1 and 2. So the final result you should have is 1, 2, doesn't matter what comes after that, but the actual returned value should be the number 2 because that's the number of unique values in it. Next example. Given nums equals an array 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, your function should return length equals 5, with the first 5 elements of nums being modified to 0, 1, 2, 3, and 4 respectively. It doesn't matter what values are set beyond the returned length. So again, what they actually want is a count of the unique values to be returned. So which ones are unique? The number 0, the number 1, the number 2, the number 3, and the number 4. That would give you the 5 uniques. And what they're saying is the first 5 elements in this array should be those unique elements. So it should be 0, 1, 2, 3, and 4. All right, so let's quickly explain what's expected in this question. First things first. They want you to return the number of unique values in the array. So let's count the unique values. We have 0, 1, 2, and 4. That's 4 unique values. So what you're going to return is 4. But the other thing they want you to do is modify this array so that all of the unique values are front-loaded. So they're put to the front of the array in order. So this array will become, and it's the same array, 0, 1, 2, 4. So you see right now we're putting all of the uniques at the front, but they don't care what comes after that. So they don't care if at the end you have all of the other 4s. So that would look like this: 4, 4, 4, 4, 4, 4. They just care that this array at least has these, and we'll show you how that's done. All right, the way to solve this problem is by using 2 different pointers. And by pointers, I don't mean the actual pointers like in C++. I just mean references to 2 different elements at once. So let's start pointer 1 at the first element. We'll just have P1 over here, and P2 pointing to the second element. What we're going to do is we're going to compare the elements that are referenced at pointer 1 and pointer 2. Are they the same? They are. So if they are the same, we just advance pointer 2 by 1 element. Now we do the same comparison. Are the 2 elements the same? They are not. So now what we have to do is we have to replace the element after pointer 1 with the element referenced at pointer 2. So see how the element at pointer 2 is the number 3? We take that number 3 and we put it after the 1. And then after we do that, we advance both pointers up 1. Okay? So now we do the same comparison. Are these 2 numbers the same? Yes, they're both the number 3. So you just advance the second pointer. Same comparison. Are they the same? Yes. Again, they're both the number 3, so you just advance the second pointer again. All right, you do the same comparison. Are they the same? No, they're not. So remember what you have to do is you have to take the element of pointer 2 and put it behind the element of pointer 1. So instead of it being 1, 3, 3, it'll be 1, 3, 5. And now you advance both pointers. All right, same comparison again. Are they the same? Yes. And at this point, we're at the last element in the array, so we just stop. So what we have at the end is this array, 1, 3, 5, 3, 3, 5, 5. But remember, the goal wasn't to sort the entire array. The goal was just to put all of the unique elements in the front of the array, which we did. And finally, how do we know what the count is of unique elements? All you do is you take pointer 1. So right now, pointer 1 is at the second index. This is index 0, index 1, index 2, and you just add 1 to it. 2 plus 1 is 3. So we have 3 unique elements. All right, so the first thing we're going to do is we're going to check whether the array that's passed in is empty. And if it is, we'll just return the number 0. So if nums.length equals 0, meaning it's empty, just return 0. Okay, now we have to create our first pointer. So let pointer 1 equal 0. So at this point, pointer 1 is right here. Now we'll create the for loop that compares the 2 different elements and always increments pointer 2. So for let pointer 2 equal 1, and it's 1 because it needs to be here. Remember that pointer 1 is already looking at element 0. So let pointer 2 equal 1. Pointer 2 is less than nums.length, so it's just going to iterate the entire array. Pointer 2 plus plus. Okay, so now what are we going to do? We're going to compare the 2 elements referenced by the pointers. So if nums just the array, so if the element in the nums array that's referenced by pointer 1, if that doesn't equal the element in the array that's referenced by pointer 2, which right now again are represented by the 2 lines in the whiteboard to the left. All right, so I'm purposely not going to fill in this if statement yet because it doesn't coincide with what we have in the drawing to the left. So remember, right now this if statement is only if the 2 elements are different, but they're not, they're the same. So what's going to happen is it's going to go to the next loop and increment the element of pointer 2 by 1. So what it's actually going to look like is it goes to the next loop and moves the pointer here. So now, again, it compares the 2 elements. Are they different? They finally are different. So what do we need to do? We need to move pointer up 1. It's going to look like this. And then replace what's in pointer 1 with what's in pointer 2. And that's going to look like, let me go back to the whiteboard. That's going to look like this. And that's going to look like this in the code. Nums pointer 1 equals the element that's in pointer 2, so nums pointer 2. And now it's going to keep going through the loop until it hits the last element. So that's going to look something like this. Are these 2 the same? They are. So we just advance the second pointer 1. Then it's going to compare the 2. Are they the same? No, they're not. So it's going to replace whatever's after pointer 1 with what's at pointer 2. So this element will now become 4. And then it's going to move this up 1. Then it'll be on the last element. Are they the same? Yes, but we're at the end of the loop, so we're done. And remember, the last step is now to look at whichever index pointer 1 is pointed at. So the index is index 0, 1, 2, but we can't just return that. We have to return whatever that is plus 1 to represent how many unique elements there are. So 2 plus 1 is 3, and if we see right here, these are the 3 unique elements. So return pointer 1 plus 1. All right, see how we did? Looks good, submit it. All right, so it's faster than 93% of JavaScript submissions. All right, so as usual, the code and the description are linked down below. See you next time.